All right. So yeah, so I will I'll tell you how to get all these classes now, right? Hopefully we'll have them saved and have them labeled so you'll know how to get them. All right, but this first week here won't be labeled, right? I just have it there now. Right, but that's not. But again, I put it. Oh no. Online, you all hear any feedback now? I know it's a little delayed, but you all hear any feedback?
No, sir. Hey, no feedback.
Stop. All right. You all hear any still?
No.
Stop. Okay, nice, good. All right, let's see how this will work out, right? So I have to leave here as the host. Anyway, we'll figure it out as it go along. The first couple of videos wouldn't be too good. Right, so as I said, we want to redo lenses today. And then what I will do is I'll message on the group. I'll do a poll again, I'll do the polls now. And we will, for the next 3 months, we'll redo some topics, right? We're going to do everything. I just now pick 3 hardest and that's what we'll review. Right, and then in March will be a crash course, and then after that, exams and all nighters and that's it. Right. All right, so as I said, we want to focus on lenses, right? We'll cut over there. Right, there are 2 types of lenses. Anybody know the 2 types of lens? Sorry, lens. Right, number 1 is your, what's this one? This is your convex lens. And what does it do to light? So when light reaches here and here, what happens? Brings it in, right? And it goes, and that's all what? What does it do? What does it do to the light? Which is converging, right? So what it does, it converges the light. So it converges the light to a special point, and that point is called your focal point. Right? So the convex lens is also a next name for it, is called the converging lens. Right, a little sideways there, but we look at it. That's the first type of lens, and then you have a next type of lens called what? Right, this one is your concave lens. Or what's the next name for it? Divergent. Divergent. So when the light comes here, the light diverges. The light diverges, right? Right, but we can extrapolate it back a little. Just draw it back. That's what extrapolation means, right? And they would be at your focal point. Right? So this is an example of what we call a diverging lens. Oh wait, I didn't add in somebody there. That's okay, copy them now, two types of lenses. And then we're going to take a look at the properties of the converging lens. All right, so these are your two types of lenses, and it's important that when the ray hits the lens, you have to know how to behave. So what is here? Although the ray is diverging in the concave lens, if you extrapolate them backwards, you're going to get image there, right? That's okay. But we'll talk about what type of image that. I have two types of images. Anybody remember? Image R. Image.
Oh.
Begin with R. And this one is B. Real and virtual, right? Real and virtual. Nice. Copy it down, and we're going to focus on the convex lens.
So the F in the back, the F on this one is 22, but what?
Yeah, both the same thing. I'll have graph paper, by chance. You don't necessarily, we will do it on a normal thing. If you add graph paper, that'll be good. Ready? Okay. Take up this one here. You can see. Now you can see, so was it two what? What's that saying? So what's the two images again? What? Which two images in? Something about real. Oh yeah, I'll give it to you. Images could be real, where the rays meet, and virtual, where the rays don't meet but appear to. All right. I'll give you that list just now. Anybody here still? Right. So there are some things that we need to know about a convex lens, right? We'll draw a lens looking like this now. Right? This here is our lens. A convex to be exact. Right? And there are some things that we need to know about a convex lens. Number one, the middle. Middle, we call that O. O is your optical center. Right? O is your optical center. Then there's an imaginary horizontal line through the optical center, wholly. Anybody knows? Pause. I know you know pause. Principal axis, right? The jug holes. Principal axis, right? So there is this imaginary line called the principal axis from the optical center, right? From the optical center, go to F. F is called our focal point. F is called our focal point. And O to F, anybody remember? No? Focal length. I must have asked me for the number. Focal length, right? Here's F, here's twice that distance. Here is F, is 2F. That's okay? This F and this 2F just giving you positions, right? Where twice the focal length is and so on, right? Anybody can just log in on YouTube and see how it's looking.
What's the name of it?
Most ideas is the Institute of Science. Yeah, I think it's Arete and it's Nicholas Paul first. Oh shucks, I didn't change the name. Alright, too late for that.
Right?
Yeah. I just want to see how this screen looking.
So you can have back and forth with your camera open.
You know, it's slow, it's lagging about I think 15 seconds. Huh?
It's 720p.
Okay. Right, so we have the optical center. Nice. See this plane here? You see this entire plane here, or this vertical area here? That's called your focal plane. It's called your focal plane. All right. If you place your object here, let's just say you place the object here, right? That the object is an arrow. So you can draw a little arrow. We can figure out where the image is. All right. So I'm going to show you how to determine where the image is, right? So these are the properties of the lens that we need to know. And we're going to talk about the image. Right, when you're drawing this, right? If you could, okay, probably you all don't show it already. All right. Next time you drawing it, I want you to use a ruler. We don't have graph paper, so you use a ruler and make sure these values are exact. All right. All right. Anyway, so we're going to learn about the image. If the object is here, when the object, the rays from the object goes through the lens, it's going to produce an image. We are going to learn about the image. All right. So let's take a look at image and properties of the image. Right? There are four properties that define. There are four properties that define the image. All right. The first thing is if it's real. The first thing is if the image is real or virtual. Right? So this is the first thing that we can say about the image. If it's real or virtual. It's real if the rays meet. It's virtual if the rays do not meet. That's okay? So if the rays meet, you're going to end up with something called a real image. If the rays don't meet, then it's virtual. Next, we're going to learn if the image is larger or magnified, if the image is the same size, or if the image is minimized, right? So the image that we're going to obtain can be three things: same size, larger or smaller. Okay? So this simply means larger, this simply means smaller. Three. The third thing that we have to look at is if it's inverted or upright. So see that there. And the last thing is its position. Last thing is its position. Right? Those are the four things that we're going to have to do to be able to describe any image. Right? Copy it down, and we're going to use ours as our first example. Here's where do it come up. I want you to draw this for a ruler. Anybody? Let's see how much we could use. I think we could use about 4 centimeters. 1, 4, 8, 16. That went okay. These are about 3 centimeters. Right? Use a ruler, and I want you to draw this here from like 3 centimeters. Of course, here to here will be 3 again. Same thing on this side. Okay, everything 3 centimeters. Cover ruler. Very good. Very, very good. That shade on. Anybody can learn shade on a ruler? Let me try. Anyone here? Fine, that's what my channel is good enough. Can't really anybody need. You have a ruler? Very well, very well. Yeah, that's my. Yeah, 2 centimeters. Everything is, oh, sorry, a real small one. Yeah, that's. Use this and then measure it. You don't have a ruler. You don't have a ruler. 3 centimeters each, right? And then you could draw object. Draw the object about 2 centimeters high. Oh, and what is here? Draw the object 2 centimeters high. That's with the arrowhead as well, right? This whole thing should be 2 centimeters. And draw it at 2f, exactly like mine. This distance here is 2 centimeters. All okay online there? All okay with that there online? Right, so here to here will be 6, here to here will be 3, here to here will be 3, and this whole thing will be 6, right? And I want you to draw your object 6 centimeters, 2 centimeters high, together with the arrowhead, right? Come on, you ready? Time's up, pencil up. Don't worry, you go about it. You know, right? So we're doing everything. Use a ruler, right? Don't do anything freehand. All right. So step number. Right. So next subheading: how to determine the image. How to determine the image. Step number 1. How to determine the image. Everybody ready? Right. So I'm going to show it and then we'll take a little note and you'll try it, right? Here's what you're doing. So you're going to take, you have to draw two rails. Everybody ready? Watch here. Watch here now. Return. Watch here. Two rails you have to draw, right? The first way you're drawing a ray parallel to the principal axis from the top of the arrowhead. When you reach,
Should I go?
yeah, straight across, parallel to this line, right? As soon as you touch the lens, you're going from the lens through the focal point. Straight line. Try to be as exact as possible, right? Start here and go through here. Wait, that's not. Go ahead. Do the first one. Go ahead. Do the first one, and I'll do the next one. Parallel to the principal axis, so try to be as parallel as possible. Right? Try to be as parallel as possible. When you reach the lens, stop and then draw a line from that point through the focal point. So it should look like mine.
So that line and have to be entire back to the convex line.
All right, how long to draw it?
Yeah.
Yeah, just draw it until it convex down. Everybody have the first one?
Yes, sir.
Yeah? Make sure it's going to the focal point, right? Vishal, you're going to the focal point? Sure. Right? Next one. You're starting at the top of the object again and you're going through the optical center. Right? So you're starting here and you are going through the optical center. And the rays should meet. Right? I just gonna cheat a little bit, right? Mine's not this key like yours. It is supposed to meet here. Yeah. I just cheat right here because mine meet too fast. I know where it's supposed to meet. So I cheat a little bit. That's okay? So you draw it from the top through the optical center. Where they meet now, watch this here. Everybody watch here. These rays came from the top of the object, right? So therefore, this part here will be the top of the image. That's okay? Right? So these rays came from the top of the object, so that will tell you where the top of the image is. And then you draw a line. Then we're going to describe the image now. It's not perfect, but it's supposed to be at 2F.
It's supposed to be good.
Yeah. Anybody online got theirs at 2F? Tell a little up here is according to how we do it. 2F, very good. That's wrong. Totally wrong. Totally wrong. Tell it off. Real wrong. Online, what you all got? It should be the image. The image should be close to 2F. If it's a little way off, that's okay. Except for Vishal. Anybody you got that 2F? No? Close? Online, why am I not seeing these messages? You meet you all again, sure? Huh? No, I'm using Zoom as a chat. Yeah, I live using Zoom. So that way, when I share the question, I want to see what will happen now. I'm gonna share the questions just now. That way, all the recordings will be there. I don't have to worry about getting it back on Zoom. Yeah. So I could always go back there and just look back at the class. And you will see yourself too. Right now it's on near. Yeah, the office will be open. All right, ready? Right, so let us go through all four now. Let us go through all four and describe the image. Everybody okay with this? Pause. You okay with this? Yeah, online. Are you okay with this? Eden or Eden, you know, reach Elizabeth. You all got this? Yeah. All right. Anybody confused online? Kevin. Kevin, you know, reach your class. Shania, you okay with us? I'm watching the wrong thing for the channels. All right, ready? So let's go. Number one. Did the rays meet? Did these two rays meet? Yes. So therefore the images real. Number two. Look at the size of the image. You might have to use a ruler. Same size? Bigger? Smaller? Check and see. Measure the image. Measure it and compare it to your object.
So one measure the height.
Yeah, the height from here to here. Same? It's supposed to be the same size, right? Again, if it was on graph paper, you would have got it a little better, right? But it's supposed to be the same size, right? Number three. Number three. Right? Is it inverted or upright? Yeah, look at it. It's upside down. Right? So inverted. Number four, it might vary for some people, but it's supposed to be where? At 2F. Okay? Right, and to be specific, at 2F on the opposite side of I feel like a spelling lens wrong. This is singular, eh? Plural is that. Remember, think about Google it fast it from what is it? What is it? What is it? Yeah, one is singular and one is plural. Alia. Plural? Plural is good. Can't remember that. Anyway, okay with describing the four properties. Yeah? Hello? Huh? Take off these for plural. For singular? That's singular? Huh? Well, I put the wrong thing in the beginning. What I had in the beginning? Okay. Anyway, copy that down. Let's try one again. Bye-bye. All right, good. Let us to Baggy say things from please. This is example number one. Number two, do the same thing. Except, yeah, we have what type to do. Right? Except don't put the object there, I'll tell you what to put it. Same, everything else is same. Same lens, same distance, and everything. Any questions online, Olia? We're gonna do our next one, right? So these are the four things here. Sorry? No, Olia, I use it. Bye-bye. Ito na Let's go again. I'll show you the calculation after, right? There's a calculation for this as well. How about it? You want to come on? Right? You're placing your object between exactly between F and 2F. Same 2 centimeters. Yeah. Yeah, right to the middle here. Right, for those who doing this Saturday class as well, remember, a shifted time, right? Tomorrow is not 11, tomorrow is some 9:30. Right? So that's all night, but I'll do all night. What? The physics class, the Saturday physics is not 11. It's 9:30. I do in the morning class online, then we have the all night after. Right, and those who come into the all night, remember it will start 6, huh? So I won't open the doors, I won't be here until 4:45. So don't come too early. Put doing the maths all night. Don't come too early, or you gotta wait outside. Unless this boy come early and open up, which I are you ready? So I do the same thing for me. Watch. This is 2 centimeters, huh? Put it in the middle. And then we are going to describe the image. Right? Next week, for next week, Tuesday, Saturday, I won't be here, right? I'll be on. Okay, just next week. I'm back to Facebook. Okay, 2 centimeters. Same rules. Right? Right, after give you the worded explanation. Huh? Watch all here. The rays don't change. Those 2 rays don't ever change. From the top here to the focal point. From the top to the optical center. Those 2 things never change. Same thing again.
Can I get a photo?
Yeah. For those who forgot, write this down now. Right? How to get the image. Number 1. I was going to tell you it in words so you don't forget it. Number one. Draw a ray from the top of the object. For all, it's for all. I give it in general 2 steps. You have to work it out. I give it in general 2 steps for finding the image. Step number 1, draw a ray from the top of the object. Draw a ray from the top of the object, parallel to the principal axis. Parallel to the principal axis. Until it meets the lens. Until principal axis. Until it meets the lens. Full stop. Full stop. Yeah, two of them are the same place. Full stop. At the lens. At the lens. Draw a line. No, same thing. Same number one. At the lens. At the lens, draw a line through the focal point. Right? So draw a line from that point through the focal point. Draw a line from the point through the
At the lens or at the point?
at the lens. Draw a line from that point through the focal line. Through the focal point, sorry. Draw a line through the focal point. Right? So from this point through the focal point, you draw a line. That's okay? That's number one. That's ray number one. Ray number two. Ray number two. Draw a ray from the top of the object. Draw a ray from the top of the object. Draw a ray from the top of the object through the optical center. Draw a ray from the top of the object through the optical center. Right, number three, last step. Last step, determine the properties of the image. Determine the properties of the image. Determine the property of the image by observing the rays drawn. By observing the rays drawn. Huh? Properties of the image. Determine the properties of the image from the lines drawn. Good. Go ahead. Do it here, and I want you to describe how you think this image will look. Huh? Yeah, this looks parallel. Yes. Right. Parallel. That's right. Do me. It will not meet between that and 12, it will be further down the road. Yeah, it will be 5. I give you a big scale. I'm gonna make this scale a little bit smaller. Show your image and describe the image. That is the answer beyond. Yeah, beyond 12. Right, so as I said, it mightn't work out perfect, right? But it will be a little way down. So here to the focal point. I have live graphic.
So when you sit in the upright, let me know.
Look at this, draw the image. If it's looking upside down or you're looking the same side. Right? So you will recognize that it's meeting quite down here. It's meeting quite down here, right? Not because it's between F and 2, if it's on media, it will be lower down, right? Right, those who online message those who online message your properties there. Wait, just check your YouTube live there. Will you see the messages? No, like when people message on Zoom. What? Let me see. No. It's so you're saying I'll see when people message, right? So those who online message answers, please. That's not weird. Just seeing somebody message.
Yeah.
Seeing that? Check on YouTube. Arian replied. Seen anything? What?
Oh crap.
I want to know. I read that long time. Yeah, those who online keep sending the answers. I want to see. Like somebody said answer. We've seen it here going. That's good. That's some private that's Zoom sharing there. All right, good job, Kiran, Arian. Let's now check it out. See if we're correct. Yeah. Jaden, let's go. Real or virtual? Real, very good. Alina. Magnify, same size or minimize? Magnify, good job. Vishal. Inverted or upright? Sure. Inverted. Correct. Over there. Sure. And last one, Ishana. Where is it? Where is it? Yeah. Well, beyond 12, right? So you don't have to say anything else. It's just somewhere beyond 12. That's okay. Very good. Right, somewhere beyond 2F, right? All right. I have a few more that we could do, right? But there's one in particular that we have to focus on. Do over the same thing one more time. Do over the same thing one more time. And we're going to put it, watch here. When you're all drawing this one, don't draw it the top of your page, bring it down a little bit. Middle of your page kind of thing, right?
So when you say it, right?
Upside down.
So what?
Look at this. Flip this over. It look like this, right? So I include it. Right?
So it was on the same place.
If this look like that, then that's upright. I'll show you one. Sorry, ma'am. And I grab paper. Drawing lines. Same thing, do the same thing. So you do the principal axis, and instead of 3 centimeters, watch, use 3 blocks. So you don't have to use a ruler. You don't have to use a ruler to do the measurements. Everything. Let us show one there. And show it on graph paper. You graph paper, we'll make sure that everyone.
Yeah.
All right, so I want you to do one more for me. Just one more. everything, same 3 centimeters, I'll tell you where to put the object. Don't do it at the top of your page, it will not work out. Right? Place the object between O and F.
Between one and
Yeah, between O and F. Something will happen. Yeah, between O and F. Sorry? Same measurements. Same measurements. Oh no. Oh my God, share. All right, let me see if I can share here. Whiteboard security. Maybe when I check back live again, I will see something. Light was moved.
yeah.
So once I share screen, I lose it.
Oh, wait a minute. I just got the conversation. Oh, I can see this.
See that? That's one. I will delete one. All right, at least it's seen it. I want to see if it's actually seen it. So that's good.
Okay, now join.
I will just delete that currently. All right, good. Y'all ready? Y'all see the little problem there? What's the problem, Alina? And not meeting it? And not meeting. Huh? Right. So the problem is that we're going to produce a virtual image here. So I want to show you how to obtain a very good position. So watch this here. Everybody ready? So I'll join it parallel here through the focal point.
2 centimeters over it.
Yeah. I join it through the optical center, but they don't meet. That's okay? These ways not meeting. So how are we going to get the virtual? We have to join backwards, right? We have to join backwards here. And describe the image to me. Take the line, draw it backwards.
Just extend the line.
On the next side, the same side as the object. So instead of drawing the line this way, draw the line the next way.
So you're drawing like that.
Huh?
You're drawing like that.
You join line when they meet, you will come down. And here you will tell me about what the image looks like, right? Are you okay with that? Oh, after you draw your way, instead of drawing a line this way, draw a line this way.
So I get
The opposite way. So draw a line here, broken out going this way. Then draw this line broken going out this way. They will meet.
so
I just draw mine a little bad,
yeah,
but I'm using it.
I get it.
Huh?
I get on it. They come and shoot out there.
F alone? F, all right. We will not calculate this shortly.
Yes.
All again, show online. Samira again, show. Right, to be sure you get through already, very good.
It's not convex.
Emily again, show.
It's not convex.
Yeah, all is convex. So you could get a virtual image on a convex.
Oh, just backward.
Yeah. Right, so we have it here, draw your line back, draw your line back. And then we're going to describe all four properties. Okay? Right, tell me the four things about the image. Ethan. You got the image? Right, tell me the four things about the image. Real or virtual? Virtual, because these ways don't meet, right? Larger, magnified, same size or minimized? Good job, Katrina. Huh? Magnified. Inverted or upright? Upright, good job. What is it again? Watch. Arrowhead on top, arrowhead on top, or upright.
Oh, so basically what you, because you watching
You're watching the object.
right.
To figure out the image. And where it is. So that's F. At F, graphic people should get at F. But watch. You can't just see at F because there's an F here too. Right? So you have to see at F on the same side as object. Okay with that? You're okay with that? Right? So those are the things about the image. Now, everything we did, we could do it by calculation, right? Everything we did, we could do it via calculation, right? The last thing I want to do today, and I want to do the past, I'll do the past papers next week, right? Right, for those who join this Saturday class, remember Saturday class is at 9:30, right? It's not 11. 9:30 until 11. Match people, you all do log in, you all will join 6 o'clock. Right, good. So there's something called the lens maker formula. Right? The lens maker formula allows us to kind of work these things out. So we don't have to always draw a diagram all the time. Right? And the lens maker formula is basically this. Right? So take a small note before you write that. The lens maker formula allows the lens maker formula allows us to determine the properties of the image. Allows us to determine the properties of the image.
So you know, like, that's for president.
Where U is the object distance from O. B is the image distance from O, and F is the focal length. Note that.
Oh, that's it.
All right, since you're here,
Oh.
note that V is negative. Right, if I'm not mistaken, these notes in the handout as well, right? Okay,
I don't know, man. The property of it is where you is the object is contact with, and then just like that.
yes, and write the formula. So you have F, U, and V. Are you okay with that? Yeah. So let's see if we can squeeze in how to use this and we're done, right? I'll come back here to. Let's go back to the first one. Go back to the first one that we did. Tell as U and F. Not this one, eh? Only example one we will continue.
It's an I over F.
Huh?
The I over F.
One over F,
Or
one on U, one on V. So we be going back to example one, right? Let's go back to example one and see if that can help us work out anything. Right. In example one, what was U? How far was the object from the, how far was the object from the, from O? Wasn't 6?
Yeah.
6, right? 3 and 3, right? So that's 6 centimeters. What was the focal length? OF is how much? 3. So everybody watch here. We can use that formula to find V. So it'll tell us exactly where the image is supposed to be. Right? 1 on F is equal to 1 on U plus 1 on V. So therefore, 1 on V is equal to 1 on F minus 1 on U. So that's 1 on 3 minus 1 on 6, which is, use your calculators and you will see 1 on 6. Right? But what is that V? This is 1 on V. So I have to flip it over. Right? Don't forget that, huh? I have to flip it over. So you'll get V on 1 is 6 on 1. So V is, sorry, here. No. Example 1 is example 3. Example 1. Right? You okay with that? So go back to example 1 and you will recognize how far was the image. Check example 1. How far was it? 6 centimeters? Yeah, Ishana? Supposed to be at 6 centimeters, right? So this is telling us a few things. This is telling us where it is. It's telling us that it's real, therefore it will be inverted. And it's telling us the position.
No, so they could that question, but I'm going to answer.
Yeah, you can find everything. So positive, so it's real. Everything real inverted.
Right.
And we know where it is at 2F. Because we know F. Right? And we'll have one more formula to give you for magnification. Actually, you know what? I could be here. Write up formula one time. That's the last thing, and I will do this while the next day is that we'll run through this and do past papers on this. Yeah. So this is your magnification formula. Write that down, right? So the magnification will tell you if it's larger or smaller, right? Did Dimitri again today? Dimitri hardly messaging boy. Up on. Everything good? I know you're a man that's message all the time. Kayla, you okay there? All right, so that brings us to the end of lenses. So now you have this video, you could always go back and look at it. Right, Vishal? So next week when you come, you know, just come early, spend a little 10 minutes and look through the video. Oh wait, next week is online. So before class starts, watch the video. All right, hopefully they might edit and cut up, take out all the little waiting periods and then. So you don't have to watch a whole hour and a half, right? Right. What number is lens in the past papers? Or what numbers is Barry and Kiran? You will have to go through it. I will send you some past papers. Right, I'll send the numbers. What's that? Physics? Nah, physics. Physics really answer. Yeah, I will do a solution by June though. For which one? Like everyone already is in the group. All right, so that's it all, yeah. You all can log out. I will see some of you all tomorrow. I'll see the rest following week. AdMass is on. If you do AdMass, AdMass is face-to-face Monday. Yeah? Everything else is online. Huh? Yeah, bye Samira. Yeah. Everything else next week is online. All right. Bye. You all can log out.